we get started, just a reminder that you can find all of my available rental properties on my website at marcguzman.com. If you own investment property, click on the Owner Services section to see our complete list of services. Thank you to our sponsor for today's episode, East Brother Beer. Located on Canal Boulevard in Point Richmond, East Brother Beer mixes classic brewing styles with precision and modern sensibility to create the perfect Bay Area craft beer. On a clear night, when looking up at the stars, it is hard not to be amazed at the vast universe that exists around us and how small we are comparative to everything around us. Every now and then, it is important to reflect on the sheer magnitude of what goes on beyond our planet's atmosphere and remember that we are just a pale blue dot in the infinite expanse of space. Today, we welcome back our friend of the podcast, Ben Burress, astronomer at the Chabot Space and Science Center in Oakland. Ben will break down the latest space discoveries and dive into some of the great wonders of the universe. Ben, thanks for coming on to the podcast for a third time.
Thanks for having me back.
Yeah, very exciting. It's always a great time having you here on the show because we talk about one of the best, most awesome subjects, and it's space and science.
I agree.
Yeah. And so for a lot of people that might not be familiar with Ben, go back to the prior episodes. We'll link them up in the description so you can go back and check out episodes, the first and second episode. So we're completing your trilogy here on the show.
Here we go.
Now, are we going to end up being like Star Wars and end up with 3 trilogies here?
Is this the rise of Ben Burress? No.
There we go. We should start naming giving every episode a unique name.
You could do that Star Wars crawl thing at the beginning of every one with the text going by and into the distance.
You know what?
Here's our intro.
You're already doing that. No?
You just confirmed. You just confirmed the second trilogy now. So let's jump right into it. The top space moments of the last decade, in your opinion.
Top space moments of the last decade. Well, I think the imaging of the black hole was kind of a big one. I know it was made up big by the scientists who made the discovery, but and in the news I know that when they said this is the first time ever we've seen a black hole, because up till then it was like you can't see a black hole because light doesn't escape from a black hole, so how would you see one? And they didn't actually see the black hole; they saw its silhouette. But the problem with the black hole is it's so small compared to the distances involved, that it's a tiny, tiny spot on the sky. It's almost impossible for a conventional telescope to get an image of. But by combining telescopes, actually microwave radio antennas around the world, and coordinating them to synthesize a massive radio telescope, they're able to get the resolution and actually get an image of the silhouette of a black hole against the background hot gas around the black hole.
Now, these telescopes that they're using, these are fairly newer technology that they've been installing in specific strategic locations around the world, right?
Yeah, it's altogether it's called the EHT, or the Event Horizon Telescope. So the idea was, and they've done this with optical telescopes and other radio telescope arrays, combining the received signal they get from a distant object in such a way that it simulates a telescope as big as the distance between the radio dishes. In this case, we're talking about radio antennas, different observatories all around the world. So in a sense, you're getting a radio telescope the size of the Earth, if you can imagine that. The bigger the mirror on your telescope or your radio receiver, the more detail you can see, the more you can magnify distant objects, higher resolution. So even though this was radio imagery, because of the size of it, they were able to get incredible resolution and be able to snap a picture of that silhouette of that black hole.
So when we look at a picture, we're not really looking at a physical picture of it.
Well,
we're looking at
what is a picture? I mean, what people think of as a picture, of course, is what you take with your camera, visible light, lenses and optics and all that, kind of the way our eyes work.
I see where you're going with this.
Yeah, okay.
A picture is really just waves.
A picture is a set of pixels. In this case, we're talking about brightness of signal across an area. So your eye does that with visible light coming in. But a radio telescope, it's just another wavelength of light. It's radio microwaves in this case. So it's still a picture. It's just not one that the human eye would ever see. So, all these different telescopes that see wavelengths that we can't see, like radio waves, X-rays, ultraviolet, the images they form are just as much pictures as a visible light image in that sense. But in another sense, they bring us more information. They show us things about an object that you can't see in visible light with your eye or with your camera. So when you use an ultraviolet camera or telescope and point it at the sun, we see different parts of the sun's atmosphere than you would with the visible light. In this case, though, you can think of it as a picture of a black hole. It's just that the light is microwave wavelengths. But the result is the same. You get a picture, right?
Now, with this information, what can we learn from it? And I think that's what everyone's now really thinking of is, especially the general public. What can we learn from it? How is this useful to us?
Right. You mean the black hole in general?
Correct.
Okay.
Yeah.
So in this case, we're looking at a supermassive black hole. This is one of those really gargantuan black holes at the core of a distant galaxy.
So this is not even our galaxy we're looking at.
Yeah, this is a galaxy, tens of light years away. Which one was it here? It's way out there. It's M87. It's a galaxy, and the black hole at the center has the equivalent mass of over 6 billion suns, or stars the size of our sun. Conventional black holes, the dead core of single stars that have died and collapsed, maybe 3, 4, 5 solar masses. But this, supermassive black holes are millions or billions of solar masses. And I think this one's like 2,500 light years, 1,000. Skip that, edit that. Way out there.
Now,
25 million. Sorry, I'm adding zeros as we go here. But
so it's M87, and I've heard that galaxy name multiple times throughout the years. That it seems like that tends to be a galaxy we focus on when we're looking at studying other galaxies. Is there a reason for that?
It's a really big galaxy, for one thing. So any M, this is the Messier catalog. Charles Messier was an astronomer.
Does it stand for massive?
No, it's just Messier was his name. Yeah, well, Messier objects are just smudgy objects in the sky. He was looking for comets, and when he found these other objects that were not comets but looked kind of hazy or smudgy, like nebulas, other galaxies, he found them a nuisance because he was looking for comets. He wanted to identify comets. So he made this catalog so that he could refer to it and know that this object he's looking at is actually a comet, not one of these Messier objects that he cataloged before. So it's a nuisance catalog for him. This was some time ago, of course. So Messier 87 is the 87th object in his catalog. But what do you learn from this image? Before they took this picture, we'd never had a direct image, even though this is a silhouette, of a black hole before. We only knew of their existence first from theory, out of Einstein's relativity, but then observational evidence involved X-ray emanations, because when gases fall into a black hole, they heat up, get very hot, and emit X-rays, or by the motion of other stars orbiting a black hole that you can't see. So indirect evidence of the physical existence of black holes is what we had before. This is sort of the first time we've caught one on camera. But it's more than that, because it's actually an image. If you look at the picture, it looks like this this hot cloud of gas with this disk in the middle, this black disk. There's information in that picture about how gravity affects light. We know that gravity bends light. As the light's moving along, gravity will alter its course. And a black hole does that in spectacular fashion. But they can use this data to make measurements of how the gravity of the black hole has bent the light, and they can use that to confirm Einstein's general relativity, make finer measurements on it and learn more about the nature of Einstein's space-time, this whole idea that space and time are all aspects of the same thing. So you're learning a lot about the nature of the universe itself by making measurements in this really amazing crucible called a black hole. That is, the forces of nature, gravity in this case, are so profoundly strong that its influence on light and space are just very extreme. So they can make measurements from that.
Do you think we will be able to determine much more than that and come up with additional theories out of this new technology and taking a look at black holes? I mean, one of the things that people are throwing around out there is, what if black holes are basically recycling the universe and spitting it out somewhere else?
Mm-hmm. That's been a theory for a long time, the whole idea of a white hole, just sort of the opposite of a black hole. One of the ideas was, where does all the matter that goes into a black hole go? Through a wormhole and maybe out somewhere else in our universe or another universe, kind of a thing. I don't know. From these measurements, I don't know if we'll, see that path any more clearly. But the more they learn about, how the black hole actually affects space around it and the light passing around it, that just adds to our understanding, of the model of the black hole, and that can be used to maybe test ideas of wormholes and all those other things we can't see. So we'll see. I mean, it's a fairly recent observation, and now they can use the EHT to look for other black holes, get more pictures, and the more data they collect, more refinements they can make.
We need to start a petition and get Elon Musk to send a rocket with a drone over to a black hole.
You know how long that would
take? 200 of my lifetimes.
At least.
Okay, so we keep hearing news of various ships, like rovers, drones, aerial crafts landing on comets, landing on Mars, and continuing to investigate, can we actually expand human life out to Mars? And we'll get into that a little bit later, but at some point in the next 10 years, where do you see us landing? Are we going to take it beyond Mars? Do you think we're going to land somewhere else?
If we land on Mars in the next 10 years, and NASA's horizon is more like in the 1930s. Sorry, the 2030s. Let me get my head out of the last century. We got back into the roaring 20s here, so now I'm thinking in terms of the 1900s. But
the close style is coming back.
Yeah, right. Now, I mean, Elon Musk wants to send people there right away, but I think NASA, takes a longer view and takes more time to work that stuff out. But I think their idea is still getting people to Mars sometime in the 2030s. Beyond that, I think it'll be a much longer time before people actually land on another planet, because Mars is relatively accessible. It's relatively close to us. Its environment, though we can't live in the environment, isn't, killer like Venus's atmosphere. You couldn't survive even in a really souped up spacesuit on Venus for very long. I think.
Well, like Elon Musk is wanting to. He's got an aggressive plan to have people on Mars by 2030.
Yeah,
and it's a very great, aggressive plan, and it's awesome if he gets even 10 or 15% close to that goal, right?
Yeah.
It's all progress. But there was an astronaut, and I forgot which one, that came out with a really good article in support of Elon Musk and what he's trying to do, but basically saying, let's take a step back and realistically look at this. And he made a very good point about Mars and the radiation on Mars and how humans wouldn't be able to last on Mars for very long because simply of the radiation. And people would have to live inside of caves in order to avoid dying from space radiation.
Right. I mean, Mars doesn't enjoy the same protection from solar radiation that the Earth does. Astronauts up in the space station are within the magnetic field of the Earth. which is, relatively strong. So it deflects a lot of the dangerous particles coming from the sun. Mars doesn't really have that, and it has a really thin atmosphere too. So if you're on the surface of Mars, there's not much between you and the sun, which is, spitting out high-speed protons all the time, the solar wind. So a lot of that reaches the ground, and X-rays and ultraviolet, other deadly forms of radiation, go right through the atmosphere there. So it's very thin. But I suppose technology could be developed to, shielding. Even the space station has, a certain amount of shielding from radiation. That's one of the technical challenges, is how to protect astronauts not only on Mars, but in transit to Mars, flying between Earth and Mars, where they're totally out in exposed space.
I've heard a few people talk about terraforming Mars and recreating the entire atmosphere that Mars supposedly had at some point.
Yeah.
Is that too far-fetched? Is that kind of in the realm of, well, if we could design the technology to do it?
It's not far-fetched.
Or am I listening to some crazy lunatics that I should stop listening to?
It's technically doable. It's just a matter of adding material to Mars. Because what we're learning about Mars through all of the landers and rovers and orbiters we've sent there, particularly recently, is that Mars's environment in the past was much more Earth-like. We're pretty sure there was now significant amounts of water, liquid water, on the surface of Mars, which means it had a thicker, warmer atmosphere. It had a water cycle, so there was rain, there's precipitation, there's rivers, lakes, and seas. So all of these things that would have made Mars a very, more hospitable environment for us. It's not to say what the atmosphere was composed of. We enjoy oxygen on Earth, but the oxygen's there because the plants on Earth put it there, and we use it. But if there was never life on Mars, then it might have been mostly carbon dioxide, which is poisonous to us. So a more Earth-like environment, we think it definitely had in the past. So recreating that and maybe adding oxygen for us to breathe, or plants to make that oxygen. There have been a lot of ideas about how to terraform a place like Mars, which already has a lot of the resources to start with. There's a lot of frozen water on Mars. There's a lot of ice in the polar cap and in the northern plains.
And that was a big discovery just a couple of years ago, right?
A few years ago, yeah. It was the Phoenix lander. It was even before that. Orbiters, detected the presence of hydrogen, which they equated with, large amounts of water ice. And Phoenix lander landed up in the northern polar plains and just scratched a little bit of the surface dust off, and then there was ice right underneath. So the estimates are there's quite a bit of frozen water in the northern plains, maybe frozen underground, in places. And there's a crater which seems to even possibly have a liquid water or slush-like lake underground down near the southern pole. So all these hints of water, not only in the past, but maybe in the present, deep underground, have been coming to light. So terraforming Mars, it's possible. Like I said, it's just a matter of, can you do it with the resources you have? The money. How many spaceships would it take to go out and haul water there? Or is it a matter of just adding time? Long period of time to seeding the place with some kind of plant, lichens, something that might be able to survive maybe in Mars's environment now, but start adding, gases to the atmosphere, oxygen, more carbon dioxide.
I've got a great story for your sci-fi stories.
Okay.
The species that will turn a planet into the planet it lives on, but then takes a planet it lives on to turn it into the planet it's trying to terraform. We're destroying Earth to make Mars look like Earth.
Sure. It's kind of like cloning Earth out at Mars, right? Yeah. I always tell people when they say, should we terraform Mars so we can go and live there? I says, well, there is the argument that if humans live on 2 planets, then we're less vulnerable to extinction by some global event, like a meteorite impact or climate change or whatever it might be. That's true. They say, so does that mean we should go and live on Mars and terraform Mars or build underground cities on Mars so that people can go live there now? I said, I think it'd be better to work on our own planet first. If we're going to put that much money and effort into making Mars another Earth, we could just as well use that to try and solve problems here and keep Earth for a while longer, right? And then, later at our leisure, once we've solved the problems here, maybe we can look at, it might be nice to make another Earth out at Mars so that...
But we've got the Space Force now. U.S. government is going full stream on this Mars deal.
Starfleet Academy? Yeah, we'll see.
So going back to Mars, one thing that they also discovered, there's also quakes on Mars.
Yeah.
So what's that telling us about the entire surface of Mars?
Well, they've only just begun to get the seismic data on Mars. Having quakes on any solid planet just means you have a relatively solid planet where there are disturbances, whether they're seismic or meteorite impacts or other kinds of motions that send shock waves through the planet. So it was always assumed that Mars probably had some form of quakes. It's not tectonically active in the way Earth is, with crustal plates that move around and driven by magma underneath. And whether it was in the past, probably was at one point when it was hotter, warmer inside. It was always assumed that there would be some kind of tremors moving through there. It's just like, if you have a bell, if something hits it, it'll ring, right? That's essentially what's happening on a planet that has seismic waves moving through it. So the InSight lander, NASA's InSight lander that landed a couple of years ago, it was sent to probe the interior of Mars, and one of the instruments it has is a seismograph, a seismometer, a big ear placed to the ground where it can, try to detect those tremors. And what I wrote down here was that since it landed, they've detected 322 seismic events, most of them very faint. But 2, in fact, were strong enough that they were able to trace back to the source of what caused the tremors. And both of them apparently came from this particular area that's, I think, known to be maybe seismically active or assumed to be. So they've just started to gather the data about the interior of Mars. One of the things they want to do with seismic data collected by InSight over time is to form a picture of the interior of Mars, understand how it's put together inside, what are its layers, how big is its core, what is it made of down there. They've done that with Earth, using seismological detectors, so listening to that ringing going through Earth caused by earthquakes and other events, to put together kind of a sonogram of the interior. And so now they're doing that with Mars. But there's only one station. It's the InSight lander. So it's kind of a beginning, but it can start developing the picture of what's going on inside. And there's a couple of other, So this is the first, spacecraft or mission of any kind that went out to probe the interior of a planet, with the exception of Juno orbiting Jupiter. It also has some experiments designed to try and probe what's going on deep inside Jupiter. So they're using indirect measurements of things like...
Yeah, I've seen Jupiter coming back on the radar in terms of articles and what they're discovering and what they're trying to do.
Yeah, Jupiter's a pretty amazing place too. Now that they have a good picture of the polar regions, they're putting together a more comprehensive picture of all of Jupiter and getting... magnetic and gravity data that tell them more about what's going on inside Jupiter. They're getting a clearer picture of that planet too. Very different planet than Mars.
So what do they think is happening inside Jupiter? Because it seems like the core of it's always been just kind of a question mark for everyone, because no one's ever really been able to send any spacecraft down to the core and measure.
Or the core of any planet for that matter. I mean, a planet's core is removed from our direct ability to get down there and examine it. no matter what planet you're talking about.
And Jupiter's unique because it's a gas planet. You don't have a solid surface to the planet.
Well, I mean, there have been a lot of early pictures I remember seeing in the old, Time Life Encyclopedia series of Jupiter, show the different possibilities, because, even now it's still debated and still being, figured out what they think is going on inside there. But everything from a solid core surrounded by a big, thick mantle of very dense, in some cases, liquefied gas, down to, I think what they're talking about now is maybe there's no solid core at all. Maybe this picture of an onion with layers, and a core in the middle, isn't, that's the picture they sort of developed over time. And a lot of people thought, oh yeah, that sounds logical. The Earth has a core and it has different layers moving out. And maybe that's also true of the gas giant. But I think some of the measurements they've been getting suggest the possibility that it may be very chaotic inside Jupiter. They're still gathering data and putting together their models, but that was one of the surprising possibilities that came out of the Juno mission.
Well, the big red eye on Jupiter, I mean, they talk about certain storms that they measured where, you think hurricane speeds here is fast, of 100, 120 miles an hour winds, but over there, we're talking about thousands of miles per hour winds.
Yeah, many in the high hundreds, maybe the low thousands, very fast winds. I mean, it's all atmosphere, especially up, at the part we can see and part we can probe to. Saturn as well has very high winds. In fact, all the gas giant planets, they've measured winds up to 1,000 miles an hour or more.
Wow.
So, yeah.
Wow. Well, Titan's also another location that I know NASA and I forget the company that wanted to partner up with NASA, but they're definitely looking at Titan. They're looking at Titan. They're looking at the possible liquid on Titan, and it's not necessarily water, is it?
It's not water. No, all the water.
Is it methane?
It's methane, pretty much. Methane, ethane, a mixture of hydrocarbon gases, which on Earth, are what come out of your stove when you turn it on.
That'd be so weird to see in person.
It's gas here. Well, if you've ever seen a cryogenic liquid, like liquid nitrogen or liquid oxygen or something, it's pretty interesting stuff. It's clear like water, but it bubbles and boils away on a room temperature surface as if it was boiling water. But yeah, Titan is probably one of the most interesting moons in the solar system. I would rate it up there with Jupiter's Europa and Saturn's other moon, Enceladus, where there are other reasons to be excited. But with Titan, in some ways, some people have characterized it as maybe being kind of a glimpse at a primordial Earth, the way Earth might have looked a long time ago. It's very cold there, which is why there's no liquid water on the surface. Any water on the surface is going to be solid rock, basically. And everything in the liquid cycle there, that is precipitation from the clouds, runoff in the rivers, and pooling in lakes and seas, is liquid methane. So there's similarities to Earth. There's a liquid cycle, there's rivers and lakes and seas, but it's a very different kind of liquid than what we're used to.
I've seen some photos, some artists put together of what it could possibly look like with the mountains and the liquid methane lakes.
With Saturn reflected in the water. And
it's very interesting.
I love those pictures that the artists put together.
Yeah.
And the thick atmosphere with its haze, barely seeing Saturn through the haze. And we have pictures from the surface, not of liquid. The Huygens probe that Cassini launched back in 2005 landed and lasted for a couple of hours before its batteries died. It actually got to the surface and took some pictures. It landed in a dry spot. There was a field of pebbles. But what was interesting about that picture was, even though it wasn't floating around in a lake, the pebbles were rounded like river rocks on Earth, suggesting maybe there had been some liquid action here that would round the pebbles through, water action, or in this case, liquid methane action.
Well, that's very interesting. Because you can see that activity here on Earth where lakes have carved out or rivers have carved out these canyons, and you can look at the material and how smooth it is, and even with sand and pebbles, like it's very amazing what water over time can do.
Right, and you've seen pictures on Titan of the river drainage networks. So these, just like on Earth, you have lots of twisty river-like things gathering, getting larger, and then coming together into large channels, and then emptying out into a big flat area, which in many cases in the pictures we've seen on Titan have turned out to be lakes and seas, some of them quite deep. The largest sea on Titan has a surface area that's equivalent to or larger than all the Great Lakes on Earth. So huge. That's why they call it a sea.
Wow.
Because it's quite big.
Now, let's go back to outside of our solar system. One thing I've been hearing about lately is we're now able to see beyond the edge of the universe, and I always, and this is why I want to ask you this question here. So, I've always heard and learned that the edge of the universe is expanding much faster than what we can actually see.
Yeah.
And so at some point we cannot see beyond that.
Right.
And there could be galaxies or who knows what else beyond that, but because of time, distance, we just can't see it. How are we now able to see beyond that, or is that a misleading, or is it maybe journalists, news outlets that are maybe not understanding the concept of what we're really discovering?
I had to turn my page here of my notes because I wrote down some very specific notes. This is a tough topic to try and understand because you're talking about the universe. And that question of, where does the universe end? People think of any object or space as sort of a three-dimensional region. Of course, to have a three-dimensional region like a bubble or something, there has to be something outside of that to make that a three-dimensional region, right? When you start talking about a universe that's potentially goes on forever in all directions, and it's one of the ideas, it just starts bending the mind. And when you talk about the edge of the universe, okay, there is a thing they call the observable universe. The observable universe being everything that we can see using telescopes and other methods of seeing objects, galaxies, and things in the distance. When you get to a certain point, you can't see any farther, kind of for a couple of reasons. One has to do with the expansion of the universe. So the model we see now is that the universe is expanding. In fact, the big surprise, one of those surprises in the last 10 or so years was that the universe is expanding faster and faster, which was completely a surprise to scientists. They thought, well, if it's expanding, even if it goes on expanding forever, it should be slowing down because it's full of objects with gravity that's all pulling backward, right? So it should be decelerating, slowing. The brakes should be applied to the universe. It might have the momentum to keep on expanding forever, but it should always be slowing down. But that's not what they found with some observations to very distant galaxies. And they're measuring the speed of expansion of the universe. And they found that it's actually speeding up. That's where the whole idea of, this is a completely other topic, dark energy.
Yeah.
Which is the new big, totally unknown thing that people talk about.
My theory on dark matter or dark energy is that it's the force. And if we can tap into it, we can choke out that one person that annoys us.
Use the dark energy. But anyway, back to your question about the edge of the universe.
It'll explain Baby Yoda.
Yeah, who is Baby Yoda? We've caught up on Mandalorian, too. But, the idea is in this universe, if you have to kind of do a mind game with yourself to think of yourself in this big expanding universe. And, even if you can't imagine this, there's ways on paper to kind of show this to be true. The farther away a point in this expanding zone, this universe, is from you, the faster it's going to be moving away from you. And they measure that through the redshift of light. So the more distant an object, the faster it's moving away. And just, the same way that a policeman will get your speed with a radar gun, you can measure the speed of distant galaxies.
Now, are clusters of these galaxies moving faster than the speed of light?
Well, no, but they're not moving through space faster than light. But there is a point at which, because of the expansion of the universe itself, an object far enough away will be moving away from you faster than the speed of light. That sounds contradictory, I know, but that's where it gets really kind of mind-bending.
I need to stop reading BuzzFeed then.
Well, but that I was trying to get back to the idea of the observable universe. Once something is moving away from you faster than the speed of light, because of its distance in this case, it becomes invisible to you. For some of those very distant objects, it's because the universe hasn't been around long enough for those objects' light to actually make it to Earth. So, and the other thing is because of the redshift, the Doppler shift, that is, as things move faster away from you, the wavelength of their light gets stretched. They become redder, and eventually that's going to stretch down to invisibility. It's going to turn light coming from a different galaxy into longer and longer wavelengths, down to radio waves, and eventually you're receiving no waves at all. So that is the edge of the observable universe, the point at which you cannot see beyond, because things more distant are invisible to you because of that. So how big is that universe? That's what I had to write down here, so if you got light years in your head, so 1 light year is the distance that light travels in a year.
Something like 9 trillion miles. 6
trillion miles.
6 trillion.
Close, very close. So 6 trillion miles is 1 light year, and that's how far you would move in 1 year, moving at the speed of light. The edge of the observable universe is estimated to be about 46.5 billion light years away.
46.5
billion light years away. And to some, that doesn't make sense, because we also hear that the universe is only 13.8 billion years old. But you have to take into account the expansion of the universe kind of doesn't take into account that speed of light thing. So it's been expanding since the Big Bang started.
Yeah, I always figured 13.8 billion years old, right? The universe is what we can estimate. So I figured, well, if it's expanding, that's going to be kind of like half of it. So I figured 26, 27 billion years distance across.
But the universe's expansion doesn't obey the speed limit of light the same way that something inside it is moving, because speed of light that we measure, which Einstein says you can't go faster than that, is relative to the space around us. And now we're talking about the whole universe expanding. It's not relative to anything else, really, at least in this little slice of the mind game you're playing. So you can kind of ignore that for the expansion of the universe. When you're talking about speed of light limitation, it's really for objects inside the universe moving along relative to space around them.
Okay.
Yeah. So
I'll just pretend I understand that.
Well, I was never deep into cosmology, so it starts to bend my mind too when I think about it too much. But you can sit down and draw some pictures, and it becomes a little clearer what I'm talking about. But that's the idea, is that the observable universe, everything we can see from our point in it, in every direction, is about 46.5 billion light years away. So it's a big space, obviously.
So if Earth was a grain of sand,
I wrote this down too. Go ahead.
How can we kind of wrap our head around this? So Earth is a grain of sand. The observable universe is what?
So I did a calculation of that. I love doing ratios and stuff with spreadsheets and whatnot, because it's a lot of fun. So I took your idea, what if we shrunk the solar system down to a grain of sand? And the numbers I applied to that was...
Okay, so we're looking at the solar system as a grain of sand, not even Earth.
Oh, yeah, that's what I picked. Because Earth size of grain of sand would be kind of... Yeah, that's not what I did. If I
Okay, so we've got our solar system,
yeah.
now a grain of sand.
And when I say our solar system, I was taking the orbit of Pluto. I mean, the solar system is arguably larger than that or smaller than that, depending on the mark you pick. But that's a big space. You know, that's pretty big. Pluto, the diameter of Pluto's orbit is like, 8 billion miles. It's pretty big. So now we're going to shrink that down to 1 millimeter. 1 grain of sand. I picked a millimeter because that's pretty small. By my calculation, the universe would be 8 million miles across. So,
wow,
it's crazy big. And the solar system, pick the Earth at the size of a grain of sand. Well, you can divide that by 8 billion if you want, but yeah, it's mind-bogglingly big.
So what's 8 million miles? I mean, where does that get us from here?
Well, let's see. So it's about 250,000 miles to the moon. So it's 32 times farther than the moon is 8 million miles. So what else is 8 million miles? The sun is 800,000 miles across. So there's nothing 8 million miles within our local area to use as a reference. But 30 times farther than the moon from the Earth.
That's mind-boggling, though.
Mm-hmm. So you get a space that big, and put a grain of sand in the middle, and that's our solar system in the universe, roughly speaking.
Wow.
Well, yeah, I just go out at night and look up at the stars and know that the stars I'm seeing with my eyes are ridiculously close to our planet compared to the rest of the universe. And yet the distances even to those stars you can see is mind-boggling, right? Mm-hmm. And you say it would take you 10 years or 100 years, or in some case 1,000 years, to get to some of these stars you can see in the sky moving at the speed of light. You just start to say, that's a big distance. I mean, that's ridiculous. So, but all of the stars you can see with your eyes are absolutely the closest. I did another ratio kind of analogy to talk about what you can see in the sky. I was comparing the Milky Way galaxy, so our galaxy, to the size of the Oakland Coliseum. And if you take all the stars of the Milky Way and you shrink them down into the Oakland Coliseum, and let's say that Earth is located at home plate. All of the stars you can see with your eyes are within the reach of the batter's swing, right there around home plate. Everything else you can't see with your eyes. You need a telescope to start seeing farther than that.
Wow.
Yeah. That's just the Milky Way. That's not the universe. That's just our galaxy. So you have to start creating these sort of comparison models when you're talking about these big distances and sizes and lengths of time.
It's mind-boggling, but at the same time, it helps you put certain things into perspective
Mm-hmm.
and how to kind of wrap your head around some of these theories and not just theories, but actual science behind it all.
Yeah. Yeah.
Wow.
It's a big topic to tackle, but with a little mathematics, you can do it.
So at the Chabot Space and Science Center, mm-hmm. what are upcoming events? What's happening there? Because I know you guys do such a great job of having new events, and especially around celestial events.
Yeah.
So what's coming up in 2020?
As far as celestial events, there's no biggies that we're doing events for. All the eclipses are not in a really good position to see. There's the usual meteor showers. We usually do 2 or 3 meteor shower events per year if you want to stay up past midnight and come up and try and see meteors. But some of our events coming up, we do a monthly First Friday event in the evening. It's a $5 First Friday coming up. Pay $5, and for 4 hours you can enjoy all sorts of hands-on activities and science demonstrations geared around a theme, as well as shows, live music, bars, all this. It's quite a fun thing. And go out and look through our telescopes if it's clear. So that's always available. Telescopes are open every weekend, but every First Friday we have this evening event from 6 to 10. And it's a lot of fun. It brings in a lot of people. the one coming up this Friday, this is the first Friday coming up, is The Sound of Science. So it's about the science of sound. So there'll be a lot of activities on acoustics and sound physics and probably a lot of music and things like that. So that's something we do every month. We also have the Bay Area International Children's Film Festival, which we've been hosting for over 10 years now.
Very cool.
Is great. It's a whole weekend of international films made by and for kids. And they're really fun. Whenever I get to work that event, I'm basically buried in the theater or the planetarium running these shows all day, but I enjoy every minute of it.
How many films are entered?
Well, I'm usually in the planetarium, and over the course of the day, I'm running, probably 8 to 10 features in there.
Wow.
Some shorter, some longer. And we have 2 theater venues, and then they run some workshops. So Jim Capobianco, who basically drives the film festival, will be there. He's worked with Pixar before. He's done a lot of creative work with Pixar, and he has his own company now. But he'll be there, and sometimes he'll run a workshop, or somebody will run a workshop on like animation techniques, and it's not really space and science stuff for the most part. Sometimes one of the stories is geared to that, but it's a fun weekend. Great for families with kids. I mean, it's definitely worth going for. And that's February 22nd and 23rd, 10 a.m. to 5 p.m. each day. In March, we're going to try a first ever of ours, Science Carnival. So it'll be another day of fun, science, learning, and education. We're still forming out the details of that quickly, because March 21st, which is when it happens, is coming up fast. So, and then later on, actually, in August, we'll be celebrating Chabot Space and Science Center's 20th anniversary at our new site.
Oh, congratulations.
Thank you. Chabot Observatory has been around in Oakland since 1883, of course, but we're at the 3rd location that we've moved our telescopes to, and certainly the biggest facility of all those. But yeah, we've been there 20 years now. We opened in August of 2000, and I don't think we've settled on the day yet, but that'll be soon. We're starting to form the day's activities. But we're going to be bringing in a lot of Bay Area and particularly Oakland partners to celebrate the anniversary with us, because over the years, I think Chabot has given a lot to Oakland and the Bay Area, but also our community partners, various organizations and people around Oakland and the greater area have certainly contributed a lot to Chabot's success. So we'll be celebrating our 20th along with the partners that have made us so successful. So those are kind of the big things coming up. Yeah, and then some meteor showers, and there's an August meteor shower, the Perseids, and then a couple in the fall and winter as well.
Great. Well, Ben, it's always a pleasure having you on the show.
Thank you.
And we always get into some very interesting topics. We're going to do a 4th episode. We're going to start the next trilogy, and we're going to make it Star Wars theme on that.
Yeah. Okay. Well, thank you so much. This is always a lot of fun.
Yeah, of course. Thank you so much for listening to the podcast. Thank you to our producer, Sam Lubman. Please subscribe, like, comment, and share the podcast. Remember, you can listen to the podcast on iTunes, Podbean, iHeartRadio, Google Play, SoundCloud, and anywhere else you listen to podcasts. For more information on my business as a property manager and real estate team, go visit my website at marcguzman.com. I really want to thank all of you for listening. It means the world to me, and I hope today's episode provides you value in your day-to-day life. I created this podcast to help showcase the many great people that live in this world and help share some knowledge that I've learned along the way in life. Again, thank you for listening. Check out our sponsors, and I'll catch you on the next episode.